Hello students, in this class we will discuss about diode resistance topic. And diode resistance, as we know, it is of two types. One is forward resistance, another one is reverse resistance. So forward resistance is always small. It is up to the order of 10 ohm to 100 ohm, and reverse resistance of diode is always large, and it is of the order of 1 mega ohm, and it almost is greater than 1 mega ohm. Forward resistance is again uh, has two types. One is static resistance and another one is dynamic resistance. Static resistance of diode is also called as DC resistance, and dynamic resistance of diode is called as AC resistance, and its value is eta Vt over IF. So when we draw the DC load line of the diode, then then this is the DC load line. It meets the 2.0 comma V by RL and V comma 0. And when we draw the forward characteristics, then this DC load line and forward characteristics meet on the point here, and this point is a Q point. This point is a Q point, and when we apply here Vd is equal to IF into R static. So here we can get the value of static resistance, and this value is Vd divided by IF. So diode is basically a non-linear device, and Ohm's law cannot be applied, but in some small reason it behaves as a linear device. So at that point we can apply the Ohm's law here. So when we talk about the models of diode, then these models are of two types. One is DC model and another one is AC model. AC model is also called as small signal model. So talking about the DC model, so when we talk about the DC model, then this is the diode in which the forward resistance is Vd and current is flowing IF. So equivalent resistance of diode, it is cut-in voltage battery, which is of V gamma, and the resistance RF. RF is the static resistance. When we apply the KVL here, so this is Vd minus V gamma minus IF RF, it is equal to 0. So we can calculate the value of IF from here. IF is Vd minus V gamma by RF. So IF is Vd by RF minus V gamma by RF. So according to this is a Y is equal to mx minus c equation, and when we draw it on the graph, then this is Vd and this is IF. So this is like a straight line. This is a V gamma. V gamma is the cut-in voltage. Cut-in voltage is the minimum forward voltage after which diode starts conduction. So after V gamma, diode is starting conduction, and this the slope of this straight line is 1 by RF. So this is meeting at this point 0 comma minus of V gamma by RF. So here are some cases. If RF is equal to 0 and V gamma is given, so this diode can be replaced. If RF is 0, so this diode can be replaced with the cut-in voltage battery. So this is the cut-in voltage battery here, and Vd is equal to V gamma in this case. And when we draw this, this is x is equal to constant graph. So this graph is x is equal to constant, where slope is 1 by RF. So 1 by 0, it is infinite. So Vd is equal to V gamma. Here we are getting here, right? So this is the first case when RF is 0, but the second case in which V gamma is also 0 and RF is also 0. So this is the case of ideal diode, this is the case of ideal diode. So in case of ideal diode, it behaves as a short circuit because cut-in voltage and forward resistance both are 0. So if both are 0, then it behaves as a short circuit, and it behaves as a short circuit. So this characteristic comes on the y-axis, is shown in the figure. So what is the AC model here? According to AC model, this diode is replaced by the dynamic resistance, which is R. And if high frequency is given, then diffusion and transition, both capacitance also appears here, and this is the dynamic resistance R here. This is the AC model. For low frequency only we have to replace with the dynamic resistance, because for the low frequency CD and CT are open circuited, because their value is picofarad, so their reactance is very high at low frequency, so we can just take them open circuit here. Okay, so this is called as AC model of diode. Let me see, there is one simple circuit here. Diode is connected, and DC supply and AC supply both are connected here. So resistance RL, which is a load resistance, output is DC and AC both. So this is the DC voltage across the diode. This is the voltage across the diode also contain DC and AC both components. Okay. Now we talk about the photodiode. What is photodiode? When a normal diode is reverse biased, then its depletion layer width increases, and when we focus the light by using the focusing lens, then the light photon is energy h nu. If this energy is greater than the energy band gap, then there are large number of electrons and holes appears in the depletion layer, and after appearing the depletion layer, these electrons and holes moves in the circuit due to the reverse bias effect, and current suddenly flows. Current suddenly increases here. So dark current is the current when no light is followed, then the current is called as the dark current, which is equal to the leakage current. Okay, so when we draw the VI characteristic here, then this is the dark current when no light is flown here, no light, then the current is dark current. When light intensity increases, like 1 lumen, 3 lumen, 4 lumen, so this current increases here. This current increases. So photodiode cannot be used in a forward biased, and the load current, the formula of load current is Q into optical generation rate into area into width of depletion layer, into Q into optical generation rate into area into Ln. Ln is the length of diffusion. Q into optical generation rate into A into LP. LP is the diffusion length of holes. So when we talk about load current, so it is calculated as optical generation rate into area into Q into W plus Ln plus LP. Okay, so current density can be calculated as current divided by area. So it is G opt optical generation rate into charge into W plus Ln plus LP. So the current IL is directly proportional to intensity of light. It is photo generated current, or it is also called as optically generated current. Now talking about the solar cell. So solar cell is just a simple connection of resistance. Here we connect no supply, and when we fall the light on the depletion layer, then again it breaks the covalent bond, and current suddenly increases. So due to IL, voltage V dash generate, which is forward biased, which is forward biasing the given PN junction. Here current is flowing, so load is connected here. So there is a voltage drop across the load, and this voltage drop will forward bias the PN junction. So net current which is flowing from IN to P, it is IL minus IF, because IF is flowing from P to N. So net current is IN to P, it is IL minus IF. IF is IS e to the power Vd upon eta Vt minus 1. So we calculate here short circuit current when load resistance is 0 here. So when load resistance is 0, then V dash is also 0. Okay. When RL is 0, then the current from P to N will be 0, because no forward biasing here. So IN to P, it is equal to IL minus IF, which is equal to IL. So short circuit current is IL. And what about open circuit voltage when RL is infinite? So I net, which is IN to P, it is equal to 0 when there is open circuited load. So net current is 0, so IL minus IF is 0. So IL is equal to IF. So IL is equal to IF. IF is IS e to the power Vd. Vd is VOC. Vd upon eta Vt minus 1. So IL by IS, this will come here, plus 1 e to the power VOC upon eta Vt. So when we calculate VOC, it is eta Vt ln 1 plus IL by IS. So this is the open circuit voltage in this case, and this is the characteristic, VI characteristic of solar cell. We can also draw if we take the magnitude of the current. So this characteristic can be also drawn in the first quadrant here. So this characteristic meets the 2-point VOC and ISC. VOC is the voltage when RL is infinite, then load voltage is 0. IS is the current when load resistance is 0. So power is also here 0. Power is also here 0. There is a value of voltage and current here where power is maximum, and when we join this rectangle, so this is called as maximum power rectangle. This is maximum power rectangle here. So here is a fill factor. Fill factor is FF. It is VMIM by VOC ISC, and this fill factor is 0.6 to 0.7 here. So this is the fill factor, VMIM by VOC into ISC. Conversion efficiency we can calculate. Conversion efficiency is eta. It is output electrical power divided by input photon power. So this is the eta max, and output electrical power is PM, and input photon power is Pin. Pin is the incident photon power or input optical power. So eta max PM can be written as fill factor into ISC into VOC by Pin. So this can be the formula of eta max. Eta max is defined as output electrical power by input photon power. This is conversion efficiency. Another efficiency is quantum efficiency, which is number of electron hole pair generated divided by number of photon incident. So number of electron hole pair generated per second, we can also define it number of photon incident per second. So Pin is the incident photon power. So number of photon incident, it is Pin divided by h nu over t. So it is Pin over h nu into t. So per second, number of photon incident per second, it is Pin over h nu. So IL is the photo generated current. So number of electron hole pair generated, IL upon Q into T. So number of electron hole pair generated per second, it is IL over Q. So when we talk about the efficiency, eta bar, it is IL by Q over Pin by h nu. So IL by P in into H nu by Q. So here IL by P in into nu, it is C by lambda. So HC by lambda into Q. So here HC by lambda, HC by Q, this is 1.24. So IL by P in into 1.24 by lambda micrometer. So this is eta bar. And the another factor is responsivity. Responsivity is called as generated photocurrent over incident optical power. So responsivity is IL by P in, generated photocurrent, it is IL, our incident optical power is P in. So it can be regarded as, it can be written as Q into eta bar our H nu, or we can also write Q into eta bar upon HC by lambda. So this answer is responsivity eta bar into lambda upon 1.24, and responsivity is proportional to lambda. So this is the graph which is called as spectral response, and this is the responsivity versus wavelength of the incident light. Okay, so this graph can also be drawn like this. Now we talk about LED, which is light emitting diode. LED LED is made up of direct band gap semiconductors, in which when recombination takes place, when electrons goes from conduction band to valence band, then the recombination takes place, then the extra energy is emitted in the form of light. So when we forward bias the PN junction, then lots of holes, large number of holes enters into N region, and large number of electrons enters into P region, and there is large number of recombination takes place. And when there is a large number of recombination takes place, then light is emitted from the junction, and this is called as light emitting diode. In the forward bias PN junction, holes are injected from P to N and electrons are injected from N to P. Therefore, large number of recombination takes place, hence in direct band gap semiconductors, light will generate. This principle is called as electroluminescence. This is a principle of light emitting diode, or this is called as injection luminescence. So in LEDs, there is a spontaneous emission. So what are the advantage of light emitting diode? It is long life, smaller size, and rugged construction, and low power consumption, and lightweight. And what are disadvantage? So disadvantage is not highly directional, it is non-chromatic. Okay, so this is a symbol of light emitting diode, and this is a symbol of photodiode. Now we talk about varactor diode, which is also called as variable capacitor diode. And the working principle of this diode is the transition capacitance. When we reverse bias the capacitance, then its transition capacitance varies with respect to applied reverse bias voltage. VRB, the formula is CT is equal to CT naught upon under root of 1 plus VRB by V naught. So the varactor diode, which is called as variable capacitor diode, and the working principle is transition capacitance. When VRB increases, then W increases, then junction capacitance Cj, which is epsilon upon W, it decreases. When VRB decreases, then W decreases, and the junction capacitance increases. So capacitance varied with respect to applied reverse bias voltage, and this is also called as varactor. So varactor is used in various places where we have to use VCO. VCO is a voltage controlled oscillator, so varactor can be used here. So it is used for direct generation of FM wave, in designing of VCO in PLL circuit, in electronic tuning or automatic tuning of receivers, and for tuning of LC resonant circuits. So in these places the varactor diode is used. Next we talk about the pin photodiode. Pin photodiode is in this diode W, which is the width of depletion layer, increases. Here we use p-type semiconductor, intrinsic semiconductor and n-type semiconductor. So due to the use of intrinsic semiconductor, width of depletion layer increases, and so in the due to the increase in width of depletion layer, the junction capacitance Cj decreases. So when width increases, so speed of response also increases. Here we use one formula, phi x, it is equal to phi naught e to the power minus alpha x. Alpha is absorption coefficient and phi is the intensity of the photon photon incident. Then generation rate of electron hole pair, it is alpha phi x. So current density J it is Q 0 to W, it is generation rate GL dx. So it is Q, and 0 to W, it is alpha phi x dx. So the value of phi x is phi naught e to the power minus of alpha x. So it is Q into alpha 0 to W phi naught e to the power minus alpha x dx. So it is Q phi naught, we will take common here. So 1 minus e to the power minus of alpha W. So we talk about diode resistance. So it is of two types, and these are the forward resistance and reverse resistance. Forward resistance is small, it is 10 ohm to 100 ohm, and reverse resistance of diode is large, it is greater than 1 mega ohm. Forward resistance is again has two types, one is static resistance, another one is dynamic resistance. Dynamic resistance is AC resistance, and static resistance is the DC resistance. So dynamic resistance formula is eta Vt over IF, and when we draw the figure, then this is the DC load line, and this is the forward characteristic, and the intersection point is called as the Q point. So this Vd is equal to IF into R static. So this static resistance of diode is Vd by IF. When we talk about models of diode, then models are divided into two parts, DC model and AC model. And AC model is also called as a small signal model. So this is the DC model where the equivalent circuit is cut-in voltage and RF resistance, and Vd minus V gamma minus IF RF, it is equal to 0. So the value of IF, it is Vd minus V gamma by RF. So the value of forward resistance, it is Vd by RF minus V gamma by RF. When we draw this figure, so this is a straight line having cut-in voltage V gamma and slope is 1 by RF. So when RF is 0 and V gamma is given, so we replace simply with cut-in voltage battery, it is V gamma. So Vd is equal to V gamma, where now in which X is equal to constant here. So this is the straight line, Vd is equal to V gamma, where slope will be infinite, 1 by RF, and it is equal to infinite. Case number 2 is V gamma is 0 and RF is also 0. This is called as ideal diode. And in the ideal diode, this becomes a short circuit. So this is the line here for the characteristic. This is Vd is equal to 0, so it behaves as a short circuit. In the AC model, we replace the diode with the dynamic resistance, but frequency is high. So for high frequency, we can connect here CD and CT. CD is diffusion capacitance and CT is the transition capacitance, and R is the dynamic resistance. So this is the circuit where AC voltage is given here, and this is the DC supply, and the output is DC plus AC both. This is the RL. Load resistance is given. Photodiode. Let me study about photodiodes. So photodiode is a reverse biased PN junction where light is focused at the junction. When we reverse bias the PN junction, then its width of depletion layer increases, and when light is focused, then large number of electrons and holes are generated here, and due to the reverse biasing, current suddenly increases here. Then dark current is defined as when no light is filled, then the current flows, which is called as leakage current, and it is I0. Then this is dark current, and current after that, when light is filled, then current increases in this way. So photodiode cannot be used in forward bias, because in the forward bias current flows due to majority charge particles, and there is no significant increase in the majority charge particles when light is filled. So IL, it is equal to Q into optical generation rate into A into W plus Q into G optical A into Ln. Ln is the length of diffusion for electrons, plus Q into G optical generation rate A into Lp. Lp is the diffusion length for holes. So G opt into A into Q, W plus Ln plus Lp. So current density JL, it is IL by A, it is optical generation rate into Q, W plus Ln plus Lp. So generated photocurrent, or IL, or it is optically generated current, it is directly proportional to intensity of light. More is the intensity of light and more is the generated current. Now we talk about solar cell. In the solar cell, we don't apply a reverse bias, only we just apply the load, and the light is filled on the junction, and the electrons and holes pair are generated, and the internal electric field in the depletion layer push these holes and electrons towards the load, and the current flows from here and to P here in the diode. But it forward bias the PN junction when the voltage V dash appears across the load. So due to IL, voltage V dash generate, which is forward biasing the given PN junction. So net current, which is from IN to P, decreases, and it is equal to IL minus IF. So net current, it is from IN to P, it is equal to IL minus IS e to the power Vd upon eta Vt minus 1. So short circuit current RL is equal to 0 when V dash is also equal to 0. So forward current is also 0 in this case, because there will be no forward bias when V dash is 0. So IN to P, it is IL minus IF, and it is equal to IL. So the short circuit current is equal to IL. Open circuit voltage when RL is infinite, then net current, which is from IN to P, it is equal to 0. So IL minus IF is 0, and IL is equal to IF. So IL is equal to IS e to the power VOC upon eta Vt minus 1. So IL by IS plus 1 is equal to e to the power VOC by eta Vt. So VOC is eta Vt ln 1 plus IL by IS. So this is the characteristic of the solar cell, and we can also draw it into the first quadrant when we take the magnitude. So in the first quadrant, this is the graph, this is VOC and ISC. This is the point when RL is infinite, but when RL is infinite, power dissipation in the load is 0, and this is the point where current is ISC. It means RL is 0, but power is also 0. But there is a point where voltage is Vm and current is Im. And when we draw here a triangle, so this is called as maximum power triangle. And the field factor is defined as it is Vm Im by VAC into IAC, and this field factor is the value which is lying between 0.6 to 0.7. Now to define the conversion efficiency. So conversion efficiency is output electrical power divided by input photon power. So output electrical power, it is PM, and input photon power, it is Pin. So Pin is the incident photon power or input optical power, which is measured in watt, and PM can be written as field factor into ISC into VOC upon Pin, input photon power. And another parameter is quantum efficiency. Quantum efficiency is defined as number of electron hole pair generated divided by number of photon incident. It is number of electron hole pair generated per second divided by number of photon incident per second. So P is the incident photon power. Number of photon incident, it is P in divided by h nu over T. So this is P in over h nu into T. So number of photon incident per second, it is P in our h nu. IL is the generated photocurrent. So number of electron hole pair generated, it is IL over Q into T. So number of electron hole pair generated per second, it is IL over Q. So when we calculate eta bar, which is quantum efficiency, it is IL over Q divided by P in our h nu So eta bar, it is IL over P into h nu over Q. So this formula is nu is the frequency, it is C by lambda. So this IL over P into HC by lambda into Q, and HC by Q, it is 1.24 by lambda. But lambda should be in micrometer. So this is the formula of eta bar, which is called as quantum efficiency. Now next parameter is responsivity. Responsivity is defined as R. It is generated photocurrent divided by incident optical power. So this is IL over P in, and the unit is ampere per watt, and it is P in. So IL over P in, the value can be written as it is Q into eta bar by HD. So R is Q into eta bar by HC by lambda. So eta bar into lambda upon 1.24, and lambda is in micrometer. So responsivity is directly proportional to lambda, and this is the graph which is called a spectral response, and this is the responsivity versus lambda graph. Lambda is the wavelength of the incident light. Now we talk about light emitting diode. Light emitting diodes are fabricated with direct band gap semiconductors, where when electrons fall from conduction band to valence band, then the energy is incident in the form of lights. So when a PN junction is forward biased, then large number of holes enters from P side to N side, and they recombine with the electrons available in the N side. Okay. Due to the large number of recombinations, there will be a large number of photons which will be incidenting from the diode. Then the light is generated. So in forward biased PN junction, holes are injected from P to N and electrons are injected from N to P. Therefore, large number of recombination takes place. Hence, in direct band gap semiconductors, light will generate. This principle is electroluminescence or injection luminescence. This is the principle of light emitting diode. So in the light emitting diode, spontaneous emission takes place. Advantage of light emitting diode is long life, small size, rugged construction, and low power consumption and lightweight. So disadvantage is it is not highly directional and it is non-chromatic. Varactor diode, it is also called as variable capacitor diode. This is the working principle is the transition capacitance. When a normal diode is reverse biased, then its width of depletion layer increases. When the width of depletion layer increases, then the capacitance also varies. Capacitance formula is Ct naught upon under root of 1 plus VRB by V naught. So when VRB increases, W increases, then junction capacitance epsilon upon W decreases. When VRB decreases, then W decreases, and Cj, which is epsilon over W, when W decreases, then Cj increases. So capacitance is varied with applied reverse bias voltage. It is called as vector. So it is used in direct generation of FM wave. It is used in designing of VCO in PLL circuit. It is used for electronic tuning or automatic tuning of receivers, and for tuning of LC resonant circuits. Now we talk about pin photodiode. So here P-type semiconductor and intrinsic semiconductor and N-type semiconductor is connected. Due to the intrinsic semiconductor, width of depletion layer is very high. So in this diode, width of depletion layer increases, hence speed of response also increases. Junction capacitance decreases. When W increases, then speed of response also increases. So phi x, which is a photon, it is phi naught e to the power minus alpha x, where alpha is called as absorption coefficient, and the generation rate of electron hole pair, it is alpha phi x. Current density, it is J, it is Q 0 to W GL dx. So it is q 0 to w, it is alpha phi x dx, and it is q alpha 0 to w phi naught e to the power minus alpha x dx. So this value becomes q phi naught 1 minus e to the power minus alpha into w. So diode resistance is two types: forward resistance and reverse resistance. Forward resistance has two types again, which is static and dynamic resistance. And dynamic resistance is eta Vp by If. Talking about the static resistance, when we draw the forward characteristic of diode, then it is the intersection point of DC road line and forward characteristic of diode. So this is Q point. So Q point is Vd comma If. So Vd is If into R static. So static resistance is Vd by If. Models of diode. Diode model is defined as two types. One is DC model and another one is AC model. So DC model is defined as Vd, the voltage across diode is Vd and the current in the diode is If. So equivalent circuit is V gamma and Rf like this. So Vd minus V gamma minus If Rf is equal to 0. This can be written by applying KVL. So If is Vd minus V gamma by Rf. So If is Vd by Rf minus V gamma by Rf. So it is Y is equal to mx minus c equation, which can be drawn in this way. So slope is 1 by Rf, and this is meeting at the point 0 comma minus of V gamma by Rf. So case number 1, when Rf is 0, V gamma is given. So this can be regarded as only the battery of cutting voltage V gamma. So Vd is equal to V gamma, where which can be drawn here. X is equal to constant line like this. So case number 2, when V gamma is 0, Rf is also 0, and this is ideal diode. So V gamma is 0, Rf is 0. So this will behave as a short circuit, and in the short circuit, this line will be exactly on the y-axis. In the AC model, we can replace it with the dynamic resistance R, and if the high frequency is given, then CD and CT appears in parallel. Now talking about the photodiode. In the photodiode, PN junction is reverse biased and the light is focused on the depletion layer. And when the light is focused on the depletion layer, large number of electrons and holes pairs are generated and current suddenly increases. And this current is a drift current. So dark current when no light is default, then the current is dark current. So this is the voltage and this is the current. Then this is the dark current, and then 1 lumen, 3 lumen. When light intensity increases, then current increases. So photodiode cannot be used in forward biased, because in the forward biased majority charge carriers do not increases significantly with the light. So the equation of current, it is Q into optical generation rate into A into W plus Q into optical generation rate into A into Ln plus Q into optical generation rate into A into Lp. So optical generation rate G opt into A into Q in bracket W plus Ln plus Lp. So current density is IL by A. It is G optical into Q into W plus Ln plus Lp. So IL is proportional to intensity of light, which is photo generated current. It is also called as optically generated current. Talking about solar cell, then in the solar cell only load is connected, but no supply is connected here. When we fall the light on the depletion layer, then electrons and holes are generated, and they are pushed towards load due to the electric field inside the depletion layer, and current flows from N to P. When current flows from N to P inside the diode, then outside it flows like this, but here when the drop across load resistance RL is V dash, then it also generates the current from P to N. So due to IL, voltage V dash generates, which is forward biasing the given PN junction. So net current, which is from I N to P, it is IL minus IF. So IL minus the IF value is IS e to the power Vd upon eta Vt minus 1. Here we define the short circuit current. So short circuit current is when RL is 0, V dash is also 0. So IF will be 0. In this case, current which is from N to P, it is IL minus IF, and it is equal to IL. So short circuit current is equal to IL. Open circuit voltage, which is RL, is equal to infinity. So net current is 0 because load resistance is infinite, it is open circuited. So IL minus IF, it is 0. So IL is equal to IF. So forward current, it is IS e to the power Vd means VOC upon eta Vt minus 1. So we can calculate from here VOC. So VOC value is eta Vt ln 1 plus IL over IS. This is the characteristic of solar cell, and in the first quadrant this graph is plotted like this, and here is the value Vm and Im, and the product of this Vm and Im, it is the maximum power, and this is called as maximum power rectangle. Now fill factor is Vm Im, our VOC into ISC, and the value is 0.6 to 0.7. This is fill factor. Conversion efficiency is defined as output electrical power divided by input photon power. Output electrical power is Pm and input photon power is Pin. So Pm can be written as fill factor into ISC into VOC by Pin. Now we talk about quantum efficiency. Quantum efficiency is number of electron hole pair generated divided by number of photon incident, or we can say number of electron hole pair generated per second divided by number of photon incident per second. Pin is the incident photon power. So number of photon incident P in our h nu by T. So P in our h nu into T. So number of photon incident per second, it is P in our h nu. IL is generated photon current, it is number of electron hole pair generated, it is IL by Q into T, number of electron hole pair generated per second, it is IL over Q. So eta bar, it is IL over Q by P in our h nu. So it is IL by P in into h nu by Q. So IL over P in into Hc by lambda over Q. So IL over P in Hc by lambda, it is 1.24 by lambda is in micrometer. The responsivity is defined as generated photocurrent by incident optical power, it is IL by P in. Its unit is ampere per watt, and this value is Q into eta bar our h nu. So nu is C by lambda, so Q into eta bar upon Hc by lambda. So R is proportional to lambda. R is equal to eta bar into lambda by 1.24, and this graph is shown like this. So after lambda C or lambda G, the energy gap, which is Hc by lambda, it is small, so this graph suddenly becomes 0 here.